Okay, so we're looking up here. We need to identify what a prime number is. I am telling you right now, 12 is not a prime number. The reason why 12 is not a prime number and 12 is going to be considered a composite number is because it has more than 2 factors. Now, when I asked what are the factors of 12, you guys looked at me like I was speaking a different language. Factors mean 2 numbers you can multiply together to get the product, the answer 12. So what are some factors of 12? 3 and 4. What else? 2 and 6. What else? There's 2 more factors. What else can you multiply together to get 12? We did 3 and 4. We did 2 and 6.
1.
And 1 times what equals 12? 12. Yeah. So because it has more than 2 factors, we know that 12 is not a prime number. A prime number only has 2 factors. Okay? So 12, not a prime number. A prime number only has 2 factors, meaning it only has 2 numbers that you can multiply together to get the product or the number itself. So let's look at 7. What can you all multiply together to get 7?
2.
No? What 2 numbers can you multiply? So what 2 factors can you multiply together to get 7? Deontay? What'd you just say? 1 and 7. Sorry, I didn't hear you. Anything else? Anything else?
Yeah, can you put this away?
Put it on my desk. Anything else? No. So 7 is going to be a prime number. It only has 2 factors. So prime numbers is where it's the number 1 and the actual number itself make it a prime number. I know you're tired, but you need to sit up for me. Kira, up. Okay, so let's look at number 4. Does number 4 have 2 factors or more than 2 factors? Can you multiply? What all numbers can you multiply together to get 4?
2.
2 and 2.
4.
So does it have more than 2 factors? It has 1, 4, and 2. So does it have more than 2 factors?
Yeah.
Yes, Deontay, put that on my desk. So
Not
yes.
even on.
So 4,
I just got there,
come on. I'm now 17 minutes in a class.
Okay.
Put it on my desk. I don't care if it's dead or alive or what it is. Put it on my desk. So 4 is going to be a composite number. So then you go to 13. What factors can you multiply together to get 13? 1 and any other ones? So does it have more than 2 factors? No. So 13 is going to be a prime number, so we're going to circle it. 80. 80. How many? Is 80 going to be a prime number?
Yeah, 10 times 80.
10 and 8.
10, yeah, 10 and 8.
Okay, we have 1 and 80.
Yeah.
We have 2 and 40.
That was not
So automatically right here, we know it's not prime because it has more than 2 factors.
Oh.
80 is going to be a composite, so we're going to scratch it. Okay? What about 81? Is it going to be prime or composite? How many factors does 81 have?
You got 9 times.
9 times 9, so 9, 1 and 81. So we automatically know that 81 is not a prime number. Okay, what about 43?
I don't know about that.
What all can you, guess what?
Prime.
It is a prime number. The only things I can multiply together to get 43 is 1 and the number 43 itself. So it only has 2 factors. What about 21? Is that prime or composite? It is composite. You're absolutely right. Because it has the factors 1, 21, but what else can you multiply together to get 21? What factors can you use to get 21? We know 1 and 21. What are 2 more?
2 and 1.
Not 2. 3 and 3 times what will get you to 21?
What day you said 34?
No, not 3 times what will get you to 21? Get your multiplication charts out, you guys, if you don't know. 3 times what will get you to 21? 7. So right there, it has 4 factors. Because it has 4 factors, I know that it is not prime, because a prime number only has 2 factors. Is 23 going to be prime or composite? 23 is going to be prime. It only has 2 factors. It only has 2 numbers you can multiply together to get 23. What about 25? Composite. What are the factors of 25? What can you all multiply together to get 25? 5 times 5 and 1 times 25, so it has 3. Okay, you want a second. What about 27? Prime or composite?
composite because you got 13.
Okay, tell me.
It was
You're right, 3 times something.
I forgot.
Somebody help me. 3 times what gives you 27?
8,
Close.
9.
9. So we have 3, 9, 1, 27. So we have 4 factors. So it is a composite number. Okay, what about 29? 29 prime or composite? 29 is going to be prime. It only has 2 factors, meaning I can only take 1 times 29 to equal 29. You're going to have to know the difference between prime and composite numbers. So number 2 says list all the factors of 30. Now remember, factors are 2 numbers that we use and we multiply them together to get the product of 30. So I always do it in order. It just makes it easier so we're not jumping around. So we're going to list all the factors of 30. So we know 1 times 30 equals 30. Can I multiply 2 times something to get to 30? 2 times what will equal 30?
10.
Not 10.
Oh.
Close.
3. 2 times 3.
15. Okay. What about, will 3 times something equal 30? 3 times what equals 30?
I believe 5.
No?
6. 10.
No? 10.
Wait.
Okay. What about 4? Can I multiply 4 by times something to get to 30? Look at your multiplication tables if you don't know. Look at your multiplication tables if you don't know. Can I take 4 times something to equal 30? No. So I have to erase that. Okay. What about 5? Can I take 5 times something to equal 30? What? Yeah. Then what's my next number after 5? Well, I'm going to try 6. Well, do I already have a 6 listed? Yeah. So therefore, I know I've listed all the factors of 30 because I don't need to go back through and do 6, 7, 8, 9, 10 because I'll just end up with the same factors. So how many factors does 30 have?
4.
No, not 4. How many numbers are up there?
3.
8. So 30 has 8 factors. It has 8 numbers that you can multiply together. Okay. Now, this next part here, number 3, it says factor each of the following. Use a factor tree. How many of you guys have used factor trees before? Oh, I guarantee you have. This is going to be helpful because it breaks it down until we get to all prime numbers. So if we look at 50, what I need you guys to do is find 2 factors of 50. What 2 numbers can you multiply together to get 50?
10.
And?
5.
Okay. Are those the only 2 factors you could use? No, you could use 2 and 25. You don't want to use 1 and 50 because that would just keep going and going and going. So it does not matter which 2 factors you use. For example, I can start with 5 and 10, but Deontay might start with 2 and 25. That's okay. So from here, we're going to break, so how we have like little branches here, we're going to go off to each branch. So 5, is this going to be a prime or composite number? Prime. Because it's prime, we're going to circle it. I circle it because that tells me it's a dead end. There's nothing else I can do with that 5. So basically, it's the prime number. We're going to break all these numbers down till they hit prime. So I come to my other side, 10. Can I factor 10? It's composite. So yes, I can factor it. 2 and 5. What 2 numbers can I multiply together to get 10? 2 and 5. Now you could put 5 and 2. It doesn't matter which order you put them. I always put my smallest number first, then my larger number. I just like to keep things organized. So then we come to each branch. Can I factor 2? Is it prime or composite? Well, think about it. Prime. Prime only has 2 factors. So what can I multiply all together to get 2? Just 1 and 2, right? So it only has 2 factors. So it's going to be prime. And we already said 5. Now, you would hope we would be done after that, but we're not. Okay? So after we factor it, we have to write this in 2 different ways. We're going to write it first in standard form and then in exponential form. So when you write it in standard form, you're going to write all your numbers out in order from least to greatest. that you have circled. We're only focused on our prime numbers that are circled. Is my 10 here circled? No, so I'm not going to do anything with that. So I'm going to come and write them first in standard form. So I'm going to put an equal sign up next to my 50. And I'm going to put these in standard form. What's my smallest prime number I have circled? 2. Then times, what's my next prime number I have circled? And then what's my next prime number I had circled? Good. So in standard form, it's going to be 2 times 5 times 5. And then I'm going to put another equal sign, and I'm going to write this out in exponential form. Exponential form stands for exponents, right? So I'm going to look at the prime numbers I have written. Do I have more than 1 2 here? No. So I'm just going to put 2 times 5. But how many 5s do I have? 2. So it's going to be 2 times 5 squared. So we have standard form, exponential form. Box it. That's going to be your answer. That's it. That's all we do with it for right now. So we're going to factor it. We're going to write it in standard form, then exponential form. Now, you're going to be confused. Hey, anytime you do something for the first time, it's going to be hard. And it's going to be confusing. But the more we practice it, the better we get. So let's practice it again. 60, I want you to factor it. We're going to make a factor tree. What 2 numbers can you multiply together to get 60? 6 and 10. What else could you use? What else could you use? 5 and something as well. 5 and 12, I believe. Okay, can I factor 6? Yeah, what 2 numbers can I multiply together to get 6? Stop, slow down, slow down. So 2 numbers I can multiply together to get 6 is 2 and 3. Now, if you're noticing, I'm working one side before I go to the other side. So then I come to my 2. Can I factor 2? No, it's going to be a what kind of number? Prime. So I'm going to circle it. It means it only has 2 factors. Is the number 3 prime or composite?
Composite. Wait, no, prime.
Prime, because it only has 2 factors. 1 and the number 3 itself. So I'm going to circle it. So then I come up to my 10. Can I factor 10? Yeah, what times what? What 2 numbers can I multiply together to get 10? 2 and 5. Now, what kind of number did we say 2 was? So we're going to circle it. What kind of number is 5? So I'm going to circle it. Now, I'm going to come up right next to the 60. I'm going to put my equal sign. And I'm going to write my prime numbers here out in standard form. Standard form means longhand. So I'm going to write it out in longhand from least to greatest. So what's my smallest prime number I have there? Then what? So 2 times 2 times what? Times, good. I'm going to put another equal sign. So there I just wrote all these prime numbers out in standard form, which means in order from least to greatest. So now I'm going to write it out in exponential form. Exponential form means I'm just going to write it in a shortcut manner using exponents. How many 2's do I have?
2.
So 2 squared, right? Times how many 3's do I have?
1.
So do I need to put that 1 there? Nah. Can I? Yeah, I can. It just doesn't mean anything. And then how many 5's do I have? Just 1. So there's your final answer. It has... Jalen had a good question. What does this exponent stuff have anything to do with anything? Everything. The whole purpose of teaching you this first is because we're going to get into square and square roots. When I say square, what number should you guys automatically think of? 2. You're going to have to identify which numbers have squares for square roots. It'll click when I get into the more in-depth stuff. It's totally confusing right now, and I expect it to be. 72. What 2 factors can I use to multiply together to get 72? Say again? 24 and 3? Okay. Nice job using your multiplication table. So, what kind of number is 3? Prime. So I'm going to circle it. Can I factor 24? What two numbers can I multiply together to get 24?
You get
All kinds of different ones.
you get that.
What ones do you want to use?
12, 2.
2 and 12. I always put my, like I said, I always put my smaller numbers first. You guys could actually put 12 first, then 2. It does not matter. What kind of number is 2? So I'm going to circle it. Can I factor 12?
Yeah,
What can I multiply together to get 12?
5. I mean,
6 and 2.
yeah.
Okay, so
You can
2
thank me, Beyonce.
and 6. What kind of number is 2? So I'm going to circle it. What kind of number is 6? Is it prime or composite? It's composite. So what two numbers can I multiply together to get 6? Well, I could do 1 and 6, but 1 and 6 I could keep doing forever and ever and ever, right?
2 and 3.
2 and 3. And those are both prime. So here, 72, when you factor it, it has quite a few prime numbers. So we're going to take these prime numbers, and we're going to write them up to the right of the 72 in standard form. So how many 2's am I going to have to write out here?
Right.
3.
So I'm going to put 2 times 2 times 2. Then how many 3's do I have? Times 2, or times 3 times 3. So that's a really long answer. But when I go to write it in exponential form, it's going to be a lot less, it's going to take me a lot less room to write it. How do I write this one in exponential form?
2 times
3 power.
So 2 to the third power
Good dang.
times 3, what? Squared, yeah.
See,
Because I,
got a 3.
Yeah.
they try to really, yeah, sorry. So 2 to the third power times 3 to the second power. So Dave had a good question, like, why don't we just write it like that, in exponential form? Because when we go to do square roots, it won't always work out evenly like that. Okay? And I'll show you what I mean by that in the next couple of lessons.
I'll low-key